Hi, welcome back. I'm Nisha. In the last video, we discussed about function. Today we are going to talk about a simple application using function. The application is how to convert a decimal number to binary number. So in decimal to binary conversion, we convert a base 10 number to base 2 number by using simple methods. For example, 12 is the decimal number, then the equivalent binary number is 1100. So how we can create this application for converting this decimal to binary? So let us start. So before moving into C++, we can check the procedure how to convert this decimal number to binary number. Okay. So the first point is divide the given decimal number by 2, where it gives the result along with the remainder. Why we are dividing this decimal number by 2? Because it's a binary number. The base of the binary number is 2 because 0 and 1 are the two digits in binary. So we want to convert that decimal number to binary, means we want to divide that decimal number by 2. So when you are dividing, we will get a result, that means the quotient and the remainder. Okay. Now see the second point. If the given decimal number is even, then the result will be whole and it gives 0 as the remainder. Is it? Yeah. When the decimal number is an even number, we know that the number will be divided properly. So we will get a whole part in the quotient and the remainder as 0. But if the given decimal number is odd number, then the result is not divided properly and it gives the remainder as 1. Okay. So repeat until the whole part is 0. So we want to divide, keep on dividing until the whole part is 0. So after that, read the remainder in a reverse order. So when all the remainder is read in reverse order, that is the binary number of that decimal number. Understood? Now see the example here. You will get a clear picture. See, 25 is the number. 25 is the decimal number. We are converting into binary number. So first we want to divide it by 2. So the quotient is 12 here. Okay, 12. Then we will get the remainder as 1 because this is not a whole. Is it? Yeah, so we will get a remainder. It's an odd number. So we will get a remainder as 1. Now we are dividing again by 2. So 6 is the quotient. We will get 0 as the remainder. Now again we are dividing 2 with 6. So 3 is the quotient. We will get 0 as the remainder. Again we are dividing by 2. 1 is the quotient and it's an odd number. So 1 is the remainder also. Again we are dividing by 2. So 0 is the quotient and 1 is the remainder. Now the whole part is 0 now. Is it? The whole part is 0. Now when all the remainder is read in reverse order, so we want to read it in a reverse order, read upward. So we will get 1, 1, 0, 0, 1. So this is the binary equivalent of decimal number. So 25 is the decimal number. The binary format of that number is 11001. Got it? So we are dividing that number by 2. We keep on dividing that number when its whole part has become 0. Then after getting that 0, read the remainder in upward. Okay. So that is the binary equivalent of that decimal number. Clear? Okay. Now we can check how to do it in C++ program. So decimal number to binary number conversion. First we can check the algorithm for how to solve this one. Step 1 is start. Step 2, enter the decimal number. So first we want to input the decimal number. Then in step 3, divide this number by 2. So we want to divide that decimal number by 2. Then in step 4, store the remainder in an array. Yeah, we want to collect all the reminders. When you are dividing by 2, we will get 0 or 1. Is it? That remainder, we want to store it in an array. Then in step 5, repeat the above 2 steps. That means step 3 and step 4 until the number is greater than 0. So when you're getting the quotient and the remainder we want to store it in an array, the quotient again we want to divide it by 2. So keep on dividing. So we will get the remainders in an array. Okay. So after that, when the decimal number becomes 0, then we are moving on to the step 6, that is print the array in reverse order. So we can print the array in reverse order. So this is a simple one. So these are the steps needed for converting that decimal number to binary number. Okay, clear? So now we can check the C++ program, how to convert this decimal number to binary number. Okay, here we are using functions, and see, convert is the function. You already know what is function. We already discussed in the last video. If any doubt is there, please go through that video. I'll put the link in the description box. Okay, see, first I included the header file iostream.h. Next is the prototype. Prototype means the declaration of that function. See, the function name is convert and the return type is void, and the passing argument is an integer 1. So here we need a decimal number, and that number we are converting to binary number. So we need a number for the conversion. So in convert we are passing a value, that is an integer 1. So that is the meaning of this prototype. No return with argument. Okay, here one semicolon is there. This shows the prototype is ending. The statement is ending. Now the program begins with void main, then int n. This is the variable we are using for the decimal number. Then we are giving the prompt to the user, enter any decimal number. This is the prompt. Then C in n means the user will input a value there in n. So now the duty of the main is over. Now this n value will pass to the convert function. So convert function will do the binary format. So convert n, this is the calling step. So convert n means we are passing a value to this function. So this is the function here. Void convert int bracket d, int d. Int d means d is the local variable of this convert function. And here why we are putting it in the header of that function? Because we are passing that value to here. So now we got the value, the user input value to that variable d. So now our task begins the process of this binary conversion. So we need an array. So we declared an array here. Int b is the array name here, and 10 is the maximum size here. Then comma I is equal to 0. One more variable declared, that I is for index for this array. Then initialized with 0. Then semicolon. Then while loop begins. Bracket d not equal to 0. D not equal to 0 means if the decimal number is not 0, we want to divide it by 2 and we want to store the remainder in an array. Is it? That is the solution. So how we can store it? How we will get the remainder here? See, b of I means b is the array here and I is the index number. I is equal to 0. So b of 0 is equal to d mod 2. D mod 2. This is the modulus operator. So d mod 2 means we will get the remainder of d by 2 in b of 0th position. Then the next is what? We want to divide this. Is it? We want to override the decimal number to the quotient of that number. So d is equal to d by 2 means we are dividing the value by 2 and we are storing that quotient in d itself. So we are updating the value here. Now I++. I++ means again we want to divide it and we want to store the remainder in array. So we need the next index number. So we want to increment the index number here. So I++, we'll get I as 1 now. Now the loop is ending, then the execution will move on to the test expression part. Then it will check that d is equal to 0 or not. If it is not equal to 0, then we want to divide it and we want to store the remainder in the array. Then again we want to override the value of d to d by 2. That means the quotient. So we want to keep on doing this process. Is it? Yeah. When d is equal to 0, the loop is ending there. Then we can display it. How we can display the binary format? See how the binary value is? We can print it in this reverse format. Is it the reverse of the array? So I is equal to I minus 1 because I is focusing to the next cell now. That is blank. So just previous of the element onwards we want to print it. So we want to move to backward. So I is equal to I minus 1 first time. Then I is greater than equal to 0. If it is greater than equal to 0, see out that element. See out that value in that array. Then I minus minus. So we are moving backward. We want to read it in a reverse order. So I minus minus. Then we are checking, is it greater than equal to 0? If it is, we want to print it. So till I is equal to 0, this loop will display the value inside that array. So this is the duty of this function. Now the brace close, that means the function is ending here. Then it will move backward to the main function. So main is also ending. So the program is ending here. So it's very simple, is it? So binary number conversion means only 3 steps are there. What are the 3 steps? One is we want to find out the remainder by dividing 2. Then the next is we want to change the value of that decimal number to the quotient of that number by 2. Then we want to store it in an array. So these are the process. Then last, we want to print it in reverse order. Okay, so I'll show you one example. So here array is B and 10 is the maximum size. So we got the array there. Now 12 is the number. We are dividing by 2 now. For example, see int n, see in n, n means n is 12. Convert n, we are passing that value to here. B of 10 is there. Then I is equal to 0. I is focusing on the 0th position now. D, is it D equal to 0? No, it is 12 now. So if it is not equal to 0, B of I is equal to B of 0 is equal to D mod 2. So we want to find out the remainder. See, we will get 0 as remainder. 2 6 are 12. We will get 0 as the remainder. So that is assigned in this array. Then again we want to divide. D is equal to D by 2 means we got the quotient as D now. We are overwriting the D value to 6 now. Again we want to divide it by 2. So this one is also not equal to 0. So B of I is equal to D mod 2 means, yeah, we want to store the remainder there and we want to find out the quotient also. So 0 is the remainder, 0 is assigned in the first position of that array, means index number 1 position. Then again it's not 0 now. So again we want to divide it by 2. Okay, so we'll get the quotient and the remainder. So the remainder is 1. So 1 is assigned here in the second index number 2 position. Then the quotient is 1. It's not equal to 0. So again, D is not equal to 0. So we want to divide it again by 2. So now we'll get 0 as the quotient and the remainder as 1. So this 1 is stored in the index number 3. That means 4th position of this array. Is it? Now D is equal to 0. Now while D is not equal to 0, then only we want to do this process. But now D is equal to 0. So now we are exiting from the loop now. Now the next point is we want to read it in reverse order. Reverse order, is it? Yeah, reverse style we want to read it. That means 1 1 0 0. But I is here now because after completing this I is incremented. So that means I is focusing on this 4th position. So we want to minus the value to 3 because I is in 4th position. B of I value is 1 here. So we want to print it on the 3rd index number onwards. Okay. So I is equal to I minus 1. Then I greater than equal to 0. Yeah, it is greater than equal to 0 because it is 3 now. So we want to print that array's number. So we will get 1. Then again loop I minus minus. So 2 will get the value 1. then again minus minus 1 we will get 0, then again minus minus, decrement the value of I to 0, so 0 also will get. So I is greater than equal to 0, we will keep on display the values inside that array. Got it? Now the output is what? The binary value is 1100. Understood? So the process is, we want to repeat the loop until the D is not equal to 0 or greater than equal to 0. Okay. So what are the process we want to do? Find out the remainder of that decimal number divided by 2 and store it in an array, and we want to change the value of that decimal number to that quotient of dividing by 2. Then we want to increment the index number because we want to keep on doing this process. Okay, then after that, if D is equal to 0, we want to print it in a reverse order. So reverse order means I is on 4th now, so we want to move it backward to the 3, then we will get the value from 1100. Got it? So this is the way of converting decimal number to binary number. Okay. I hope you all understood the concept of binary number conversion and the usage of user-defined function. This is a simple application by using user-defined function. So in the next video, I will show you the detailed in different methods of arguments using in functions. So till then, take care. See you all. Bye. Thank you.